Very good afternoon and welcome to Prep Funder. This is Sanjay Rathi. How are you guys? Now that is a very important session on Thevenin's and Norton's theorem, guys. Okay. So this is the very important topic. Every year we are getting question from these two topics. 1 marks or 2 marks question. Normally 2 marks question. It may be numerical answer type. It may be MSQ or it may be what MCQ. And it is suppose we are going to solve around 10 to 20 questions on this topic, then automatically you are going to get command. So I am going to solve some important questions. Today we will discuss Thevenin's and Norton's with normal independent sources, and then after that in next session we will discuss Thevenin's and Norton's theorem with dependent sources. So with these two sessions you will get command over this topic, guys, and I am going to solve some previous year question as well as some questions from standard textbook, guys. Okay, like what? Van Valkenburg, Sadiku. So I think everyone ready. So please share the link of this session and subscribe our channel, because we are going to take some important and session for you, right? And normally it will be in two languages, Hindi or English. So this session is in English. Okay, so you can subscribe our channel, like the session and share the link of this session so that the student will join, guys. Okay, done. Now this is a network circuit theory through questions. I think sound quality, picture quality, everything is fine. Please check. Okay, I think everything is fine now. So now I am going to solve some important question for you. First of all, this is a Thevenin's and Norton's theorem. The name of the series is what? NetworkNavigator, your guide to network concepts, right? So under this series we will take what sessions for network, right? And sometimes we will cover some theory, or sometimes we will cover some important questions. So this is the network or circuit through questions, and try to solve this question, that is the Norton equivalent circuit of the circuit in the figure at terminal A and B. So across A and B, try to find the Norton's equivalent. What is the Norton's equivalent, guys? Okay, then try to solve this question. Then now all fine. Bhanu Prakash, how are you after long time? Then this is the 2 ampere current source, 4 ohm, 8 ohm, 8 ohm and 5 ohm. You have to find the Norton's equivalent across the 5 ohm. Please take the screenshot. And now I will cover my part, because it is a new channel. This is my introduction. Myself Sanjay Rathi, 24 years of teaching experience, and that is my achievement. I have qualified and selected for engineering services exam, जो कि अभी होने वाला है after 2 days, right? Or just day after tomorrow. There is an engineering services mains. So I have qualified and selected 4 times. These are my ranks: AIR 16 in ESC 2005, AIR 21 in ESC 2008. And I have trained more than 1 lakh students through offline classes and through online classes, right? In Medici, in Unacademy, in Byju's, number of lectures are present, and throughout the India, right? Just I have taught number of students. So you can also get top rank in any exam, guys. So just follow my experience, and that is my Telegram channel. You can join, Electronics by Sanjay Rathi, right? So for daily dose to improve concept, if you want the PDF of these sessions on network, so you can join, right? And I will upload the PDF on this. I am fine, Bhanu. Good. So बस ये है, this is a new endeavor, guys, for you. Just up to gate examination, I am going to provide some important topics and important questions from what various subject. For example, network, EDC, analog, digital, control, okay, signal and system, and so on. So these are the number of subjects we will deal, and in comments box or in my Telegram channel, give me suggestion on which topic you want session, right? So I will try to cover those topics. Then, so that is my Telegram channel, Electronics by Sanjay Rathi. Link is available in description. Then that is the schedule for that, network schedule. So already I have taken how to cover the network. So you can watch this session. How to cover network means I have given each and everything about the network, and before that I have taken one session 50 plus 30 plus 10 plus 5. So with these two sessions, you will get idea how to cover the complete syllabus for GATE or any competitive exam. Then guys, already I have covered KCL, KVL, mesh and nodal analysis. Try to solve. I have given some assignment. I will arrange one session where I will solve all the assignments. So try to solve all the questions and then watch my solution for those questions. Today again I will give some questions. Then in this session I will cover those assignments. On 24th June at 4 p.m. I have Thevenin's and Norton's theorem with dependent sources. Then guys, two-port network, Z and Y parameter, H, ABCD. So first please take the screenshot of that. First order transient and first order transient for RL circuit. And according to your response, I will cover next topics like what steady state analysis of sinusoidal signal, resonance, series, parallel resonance and so on. Yeah, that is the series. Now, yeah, this is the first order transient RL circuit. So you can take a screenshot, subscribe the channel so that you will get the notification. And that is the comprehensive course on analog electronics, guys. So I want to inform you one thing. Already I have started analog in morning 6 to 8 p.m. or 6 to 8 a.m. You can also join complete analog. The fee is very reasonable. You can join. Right, for more detail you can message me on my number that is given in what this channel or on my Telegram channel. Complete analog in a detailed, because we have I'm directly going to interact with you. Pura discussion hoga. You can ask any type of questions. So within 1 month you are going to get the command over analog. So ये है comprehensive course. If you want to attend the demo lecture, and that is at 7 p.m. on YouTube on same channel, ideal and practical diode with numericals, so that you will get the idea how I am going to cover the complete analog. So already I have uploaded one, and that is the second one. Okay, sir, take session on AC analysis. Bilkul, theorem on AC analysis, definitely Bhanu. Just after that I will. So one by one already I have sequence for that. So stay tuned with me. Subscribe channel so that you can attend. At the 7 p.m. definitely try to attend this session. 7 p.m. on the same channel. I will share the link on my Telegram channel. So here is 7 p.m. 2 hours class from paid classes, live paid classes, demo lecture. You will get the idea about the analog. And that is the Thevenin's and Norton's on 24th of June, 4 p.m. Daily at 4 p.m. network. Then, अब आते हैं, what is the Thevenin's theorem? Already I have given question. Just I will give you the brief idea about the Thevenin's and Norton's, and then guys we will solve number of questions because it is a network through questions. So what is the Thevenin's? Simply if you have any network, then you can convert this network into single voltage source and in a resistance series with that. You can convert any two-port network. This is the network. This is we are taking the output. So you can convert it into what? Single resistance and single voltage source, and that is called Thevenin's equivalent across A and B. So that definition is very, very important. Thevenin's theorem states that any two-terminal linear network, this is important, two-terminal linear network having a number of voltage or current sources. It doesn't matter how many current sources, how many voltage sources, dependent, independent are present. You can convert this into a simple equivalent circuit of consisting single voltage source in series with a resistance. Now, what is the voltage source? It is called open circuit voltage at this point, open circuit voltage. And what is the resistance? We are calculating the equivalent resistance by seeing at this terminal. So with numerical you will get the idea. Then similarly, what is the Norton's theorem? In the Norton's theorem, what we are doing, it is a linear network. Just remove the RL, and then that complete network is converted into a current source, or in a parallel we are having the resistance, that is called Norton's resistance, and finally we are connecting the RL. So this is the equivalent of this particular network, and that is called Norton's. What is IN? IN is nothing but short circuit current. Take network, always remember the method. Take network, if RL is connected, remove the RL. Find the open circuit voltage, that is called Thevenin's voltage. Take network, remove RL, find the short circuit current, that is called what? Norton's current. Norton's current. And what is the RTH or what is the Norton's resistance? Both are equal. That is the open circuit voltage upon short circuit current. What is the open circuit voltage? VTH. What is the short circuit current? IN. So that is about the Thevenin's and Norton's. Very brief definition. Why? With numerical you will get command. So are you ready to solve some numericals? How's the Joes? Right. तो चलिए देखते हैं. एक चीज मैं आपको बता दूं. I'm just in next few months I'm going to take very important sessions for you. ठीक है, जैसा आप सजेस्ट करोगे और मैं अपने एक्सपीरियंस के साथ I will take number of sessions on all important subject. Right? तो बस आप बनाते रहो. जैसा जैसा मैं असाइनमेंट बोलूं, जैसे मैं नोट्स बोलूं या मैं जैसे आपको टेक्स्ट बुक सजेस्ट करूं, ट्राई टू गो थ्रू दैट. Try to solve the assignments, try to solve questions, try to go through those textbook. Definitely you will get the top rank in exam. Okay. Then अब ये देखो पहला क्वेश्चन डायरेक्ट है. Norton's equivalent circuit of the circuit in figure at terminal AB. I will find Norton's equivalent as well as Thevenin's equivalent of this diagram. So what is the Norton's equivalent and Thevenin's equivalent of this particular diagram? Remember, this is a 2 ampere current source. This is a 12 volt battery. I think it is visible. 4 ohm, 8 ohm, 8 ohm, 5 ohm resistor it is given. Now we have to find a Norton's equivalent. Then how we can find a Norton's equivalent for this? So watch this. To find the Norton's equivalent, first of all, how to find the resistor? If you want to find the Thevenin's resistance or Norton's resistance, if there are independent sources, then it will become very easy. Current source will act as open circuit and voltage source will act as short circuit to find the RTS. To make it short and make it open, you will get this type of diagram. You will get this type of diagram. Make it short circuit. This is the 4 ohm. This voltage source is short circuit, current source is open circuit, 8 ohm, 5 ohm, and that is the 8 ohm. And now across A and B, you have to find Thevenin's or resistance. So this is the 4 ohm, this is the 8 ohm, this is the 8 ohm, and that is the 5 ohm across AB. Okay, now these three resistors are in series and that is in parallel. So what is the resistance seen here? This is called Rn or it is also called RTH resistance seen here. So यहाँ से देखेंगे from this side. So these three are in series and that is in parallel. So what is the RTH? RTH will become 8 plus 8, 16 plus 4, 20 parallel with 5. So 20 into 5 divided by 20 plus 5 and you will get the 4 ohm. So what is the RTH or Rn? 4 ohm. Both are equal, that is the 4 ohm. Right? Now, how to find a Norton's equivalent? We have the two methods. For example, because RTH or Rn is equal to VOC upon ISC. So what is the ISC? ISC will become VOC upon RTH. Because already we have the RTH, then VOC upon RTH or directly you can find the short circuit current. So we are going to use both the methods. Then second, short circuit current, first of all make it short circuit. That will become ISC or IN. Then what is the voltage at this point? This is not 0. Remember, this is not 0 because this is the 0 reference. So that is the short circuit current. Now how we can find? Okay. So there is a method. We have to find a ISC. Same current, same ISC will flow like this. Why? Because it will short circuit the 5 ohm. So this is the ISC, this is the ISC and that is the ISC. Okay. And then this is the 2 ampere. So you can simply write this is the ISC, this is the 2 ampere. So what is the current here? 2 minus ISC. How we can say? ये देखो यहाँ से 2 ampere incoming है, outgoing is ISC. So what is here? 2 minus ISC. Okay. Now can you find the ISC? Very simple. Write down the KVL. Write down the KVL from this point from this side to this side to this side. So what is the KVL here? Minus 12, this is plus minus 4 times of 2 minus ISC plus 8 ISC, this is the 8 ISC, this is 0 plus 8 ISC is equal to 0. Now you can 12 minus 8 minus plus 4 ISC plus 8 ISC plus 8 ISC is equal to 0. 8 plus 8 plus 4, that is the 20 ISC is equal to 20. So what is the ISC, short circuit current or Norton's current? ISC will become 20 divided by 20, that is the 1 ohm. 1 ampere, sorry, 1 ampere. तो 1 एम्पियर आ गया आपका नॉर्टन्स करंट और आपका बाकी आ गया थेवेनिन्स सॉरी आरटीएच. व्हाट इज द आरटीएच हियर? 4 ओम. तो आप वीओसी भी निकाल सकते हो. आईएससी इंटू आरटीएच इज इक्वल टू व्हाट? वीओसी, दैट इज कॉल्ड वीटीएच. तो वीओसी दिस इज नथिंग बट वीटीएच, दैट इज नथिंग बट आईएससी इंटू व्हाट? आरएन. 1 into 4, that will be 4 volt. We will verify it. We will verify whether we are getting 4 volt, yes or no. In this way we can, yes Bhanu Prakash, you have given the right answer. In this way we can verify it whether we are getting the right answer or wrong answer. तो चलिए ये तो आ गया 1SC, यही है. तो नॉर्टन्स इक्विवेलेंट क्या होगा इसका? नॉर्टन्स इक्विवेलेंट बन गया आपका सिंपल सा, दिस इज द RN, IN 1 ampere and RN 4 ohm. And what is the Thevenin's equivalent? That is the source transformable pair. So how the current source is converted into voltage source? This is multiplied with this. So you can find the VTH. So VTH is nothing but current into resistance, that has become 4 volt, and resistor in parallel. That will become RTH. RTH is RN, that is the 4 ohm. This voltage source VTH is nothing but ISC into IRN. So source transformable pair, Thevenin's and Norton, source transformable pair. तो आपको ये, this is the Norton's equivalent and that is what? Thevenin's equivalent. Now can we verify it? Verify it. Or similarly, if you have the Thevenin's, you can find the Norton's. 4 divided by 4, you will get the 1 ampere. But we have to verify whether we are getting VOC 4 volt, yes or no. VOC, VTH 4 volt. Now watch this. How we can find? Simply, you can apply the superposition theorem, or you can simply remember, guys. We can find a voltage at this point Vx. I am going to apply the nodal analysis first of all. Remember, this is the ground. So 1, 2, 3, these 3 resistors are in series, right? Can we write the KCL at this point? Tell me, is it possible to write the KCL? Or can we apply the mesh analysis for that? Can we apply the mesh analysis for that? So we can apply the mesh analysis also. How we can apply the mesh analysis? Watch this. We want VOC, so let you can take, this is the I2 and let this is the I1. So everyone use this method. So I1 will become 2 ampere. I1 will become 2 ampere. VOC will become 5 times of I2. VOC will become 5 times of I2. We have to find the I2 only. Now I am going to write the KVL. So this is the minus 12. So I am going to write the KVL from this point. So this will become minus 12 plus, what is the current here? I2 minus I1. I2 minus I1 into what? 4 plus 8 plus 5 plus 8. 8 plus 8, 16 plus 5, 21 times of I2. 21 times of I2, and that KVL is over, is equal to 0. Now this is minus 12 plus I2, 4 I2 minus 4i1. What is the i1 here? 2. 4i1 plus 21 times of i2 is equal to 0. Now watch this. 21, this is the 25 minus 12 plus 25 times of i2 minus 8, because i1 is this, i1 is 2 ampere, is equal to 0. Minus 12 plus 8, that is the 20. So i2 will become 20 divided by 25 ampere. 20 divided by 25 ampere. What is the VOC? VOC is nothing but 5 times of I2. VOC is VTH. It will become 5 times of I2. 5 into 20 divided by 25. We are getting the 4 volt. Verified? Yes or no? तो देखो यहां पर मैंने इसका थेवेनिन्स भी निकाल दिया और नॉर्टन्स भी निकाल दिया भाई, तो वेरीफाइड हो गया ये तो. थेवेनिन्स एज वेल एज व्हाट नॉर्टन्स, बोथ वेरीफाइड गाइस, बोथ वेरीफाइड. तो ऐसा आपको हर क्वेश्चन में आप थोड़ा सा सेटिस्फाई करेंगे ना तो आपका कॉन्फिडेंस बढ़ेगा, आपको बात समझ में आएगी कि कैन वी सॉल्व दिस लाइक दिस और यस और नो. नाउ नेक्स्ट क्वेश्चन. तो ये हो गया एक, एंड दैट इज अ गुड क्वेश्चन फ्रॉम अलेक्जेंडर एंड साडिको. Thevenin. So what is the answer for this question? Because the Norton is required, so answer is D. 1 ampere 4 ohm. 1 ampere 4 ohm. Next one. This one. बोलिए जरा. The Norton's equivalent seen at the terminal AB of the given circuit. चाहे Norton's निकालो चाहे Thevenin's आप निकाल सकते हो. Norton's equivalent seen at the terminal AB of the given circuit. Where is the AB? ये A और ये B. इसके अक्रॉस आपको निकालना है. क्या होना चाहिए? मतलब 1 ओम के अक्रॉस निकालना है, AB टर्मिनल के अक्रॉस आपको Norton's equivalent निकालना है दोस्तों. राइट? ये 1 ओम रजिस्टर दिया हुआ है, ये आपका 3 ओम रजिस्टर दिया हुआ है, ये 4 ओम दिया हुआ है, ये 2 ओम दिया हुआ है. अब देखो अगर ये करंट सोर्स है 2 एम्पियर, तो जब इसके अक्रॉस आप रजिस्टर निकालोगे तो वोल्टेज सोर्स विल एक्ट एज शॉर्ट सर्किट एंड करंट सोर्स विल एक्ट एज व्हाट, ओपन सर्किट. तो यहाँ पे 14/9 और 3/2 ओम रजिस्टर दिया हुआ है. तो सबसे पहले आप रजिस्टर को वेरीफाई कर लो कि क्या रजिस्टर की वैल्यू कैसे आ रही है. और इसमें एक और छोटी सी प्रॉब्लम है, जैसे इसको ना MSQ तो दे दिया है, लेकिन ये समझ नहीं आ रहा है कि यार ये R1 जो है वो RL है कि क्या है, क्योंकि अगर वो RL है तो उसको आप वहां से रिमूव कर सकते हो. राइट? लेकिन अब यहां पर देखो जरा, इस पॉइंट पर जो भी आंसर आएगा पहले तो हम A भी निकालेंगे. तो ये दिस विल एक्ट एज शॉर्ट सर्किट. ये शॉर्ट हो गया. मतलब देखो जब भी शॉर्ट करोगे ना तो ध्यान रखना, अगर ये A लिखा हुआ है, ये B लिखा हुआ है, ये C लिखा हुआ है, ये D लिखा हुआ है, तो आपने A और B को शॉर्ट कर, A और D को शॉर्ट कर दिया और इसको ओपन कर दो भाई, इसको ओपन कर दो. ये करंट सोर्स ओपन हो गया. जब रजिस्टर निकालना है तो करंट सोर्स ओपन हो गया. राइट? अब देखो ये जो 2 रजिस्टर है ये दोनों आ गए सीरीज में. दिख रहा है आप लोगों को? ये यहां से कुछ भी नहीं है यहां तक है, तो ये पूरा B से लेके वापस, तो 3 और 4 ये 7 आ गए सीरीज में. तो आपको दिखाई देगा ये A और B के बीच में एक रजिस्टर है 1 ओम, ये A और ये B. उसके बाद ये सीधा ये 3 और 4 आ गए सीरीज में. वन और 3 और 4 आ गए सीरीज में. एंड देन अब देखते जरा A और B के बीच में ये भी A और D भी मर्ज हो गए, तो ये 2 ओम भी आ गया सीरीज में, पैरेलल में इसके. तो भाई साहब कितना है 2 ओम. मतलब क्या क्या पैरेलल में आ गए, ये तीनों पैरेलल में आ गए. तो तीनों का पैरेलल कॉम्बिनेशन क्या होता है, 1/R इक्विवेलेंट, दैट इज नथिंग बट RTH इज इक्वल टू 1/7, ये हो गया 1/7 प्लस 1/2, ये वाला हो गया 1/2 प्लस 1/1, क्या लोगे एलसीएम 14, 7 दूनी 14 और ये 7 इंटू 2 प्लस वॉट 7 प्लस वॉट 14 होगा, ये हो गया 14। तो आप बताओ कितना हो गया 14 प्लस 7 21 प्लस 23 अपॉन 14 और इसका रेसिप्रोकल निकालेंगे तो 14 अपॉन 23 14 अपॉन 23। पहले तो आपको वेरीफाई करना है कि आंसर है या नहीं है। यार ये तो नहीं है, 14 अपॉन 23 तो नहीं है, 14 अपॉन 9 जरूर है। अब यहां से आपको जो कंफ्यूजन था, मुझे जो कंफ्यूजन था कि क्या इसने इसको लोड कंसीडर किया है क्या? यस, इसने 1 ओम को क्या किया है, कंसीडर किया है लोड। और अगर आपको लोड कंसीडर, क्योंकि ये ऑब्जेक्टिव से समझ में आता है, आंसर से समझ में आता है, अब आपका तो नहीं आ रहा है 23/14, तो उसने क्या किया, उसको लोड कंसीडर किया 1 ओम को। और अगर 1 ओम को लोड कंसीडर किया है तो फर्स्ट ऑफ ऑल इफ इट इज कंसीडर्ड एज लोड 1 ओम, then you have to remove that 1 ohm. So when I am removing 1 ohm, so what will be the circuit, tell me guys? When I am removing the 1 ohm, तो देखिए this is out. Now 1/7, this is the 7 parallel with 2, and when the 7 is parallel with 2, what will be the answer across AB? 7 parallel with 2, that is nothing but 7 into 2 upon 7 plus 2. What is the answer? 14 upon 9 ohm. So we have answer 14 upon 9. Yes, we have the 14 upon 9. This is the 14 upon 9. This is the 14 upon 9. So there may be two options, A or C. B wrong, D wrong. Okay. So ये है, we have to remove the 1 ohm load from this point. We are getting. It is considered as now. Second question, Norton's equivalent means what is the short circuit current across AB? When we have to calculate the short circuit, then guys you have to consider the 2 ampere as well as 3 volt. Simply first of all remove this one. First of all remove the load. 1 ohm load is removed. Now terminal AB is short circuited. Terminal A and B is short circuited. And this is the ISC, Norton current. AB is short circuited and this is the case guys. अब आप बताओ how we are going to calculate this. चलिए बोलो, सोचो जरा. Now you can take it as a what reference. You can take it as a reference, and this is the 3 volt battery. Now remember, if this is the 3 volt, this is also 3 volt. This is also 3 volt. So if this is the 3 volt, then it is also 3 volt. So what will be the current here? 3/2. Because this resistor is 2 ohm. So what is the current here? 3/2. Here the current is ISC. So what is this? ISC. I am just writing the KCL. Incoming is ISC, outgoing is 3/2. So it will become ISC upon 3/2. Are you getting my point? This is the ISC. This is the 3 divided by 2. So ISC minus 3/2. Now you can add the 2 ampere. So it will become ISC minus 3/2 plus 2. What is the 3/2? 1.5 and 2 is what? Minus 2. So that will become 0.5. It is nothing but ISC plus 0.5. ISC plus 0.5. You can add this current at this node, apply the KCL. This is plus that, and this current will flow like this. Right? Now, where we can apply KVL to just find the value of ISC. So you can apply the KVL at this node from this point to this point to this point just to find the ISC. When I am going to apply the KVL, it will become 4 times of ISC minus 3/2. This is the 4 times of ISC minus 3/2 plus 3 times of, this is the 3 times of ISC plus 0.5, and then 0 is equal to 0. Then it will become 4 ISC minus, this is the 6 plus 3 ISC plus 3 into 1.5 is 1.5 is equal to what? 0. Now 4 plus 3 is 7 ISC, and that will become 4.5. So ISC is equal to 4.5 upon 7. When it is multiplied by 2 divided by 2, it will become 9 by 7 ampere. So according to me, that is the answer. What is your answer, guys? What is your answer? क्या आंसर है भी कि नहीं भाई? अरे यहां पर देखो क्या गड़बड़ करता हूं मैं. 7 इंटू 2 14 होता है ना. ये देखो, ये तो देखो, दिस इज कॉल्ड कैलकुलेशन मिस्टेक. लास्ट वन इज 7. मैंने वो 2 and 2 जस्ट टू मेक इट व्हाट परफेक्ट फ्रैक्शन, तो 9/14 आ रहा है. अरे 9/14 भानु. Okay, that is the first option, 9/14 ampere. 9/14 ampere. So what we have done, just in the diagram itself, I have applied what? KCL. What is the current here? ISC. So what is the current here? The voltage, that 3 volt. That's why it is a 3 volt. What is the current here? 3/2. What is the current here? ISC minus 3/2 plus 2, and so on. And write one KVL only. This is the KVL, and you will get the answer. ISC is equal to 9/14. अच्छा, एक बार जो इजी है ना, if suppose this is the KVL, you will get the ISC and VOC. So it is a very easy to find the VOC. What is the VOC? I have already said ISC into RN. ISC is 9/14. RN is RN 14/9. What is the VOC? 1 volt. This is nothing but VTH. This is nothing but VTH. 1 volt. VOC is what? 1 volt. Can you verify it? By practice, make practice, so that you will get the right, whether we are getting the right answer or wrong answer. Whether we are getting, yes, 1 volt. So you can verify it. For example, just remove it. Because this is the RL, 1 ohm is the load, remove it. Now, at this point, we are getting VOC. That is the reference. Now, let this voltage is VA, this voltage is VB. So, VA is fixed. VA is what? 3 volt. So, VOC is nothing but VA minus VB. And what is the VA? 3 volt. You have to find the VB. You have to find the VB. How you can find the VB? Tell me, guys, quickly. How you are going to find the VB? सोचो जरा कैसे बनाओगे. Bhanu, you are from AP, okay. From AP. Tell me, जल्दी बताओ भाई, VB कैसे निकालोगे और VOC कैसे निकालोगे. अल्टीमेट तो गोल है VOC निकालना है. देखो ये ओपन है, देयर इज नो करंट इन दिस लूप, और वहां दैट इज अ 2 एम्पियर करंट सोर्स. So what is this? Simply that what is this is the VB. So what is the voltage current here? VB/2. Right, simply VB, तो VB/2 is the current. So what is the current here? Same series है ना, तो VB/2. So that is the current from VB/2, VB/2. Okay. Now, if this is the VB/2, so this is the 4 plus 2, 6. So what is the voltage at that point you can find. Now, if you have the voltage or you have the current, what is the current here? This is the VB/2, this is the 2. So this will become 2 minus VB/2. 2 minus VB/2. Right, now we have the current. Can we apply the KVL? Yes, we can apply the KVL. Always remember, we can write the KVL in a closed loop. We can write the KVL in a closed loop. Right, we can't write the KVL with the current source. I will give you the shortcut. Now, from this point to this point, you can write KVL. This is the closed loop. and you will get the value of the VB, and VA minus VB is equal to what? VOC. Simple. चलिए देखते हैं, हमारे पास आंसर ऑलरेडी है 1 volt. Now check. This is because the current is in opposite direction. This is the plus minus. Plus minus. This is the plus minus, and that's why it will become 2 plus 4 6 minus 6 into VB by 2 plus 3 times of 2 minus VB by 2 plus this is the 3 is equal to 0. You can choose any easy method. Minus 3 VB plus 6 minus 3 VB by 2. Right, this is the 6 minus 3 VB by 2 plus 3 is equal to 0. Right, that is the case. Now this will become 9 VB by 2 is equal to minus 9. This is the 6 plus 3, minus minus cancel, 9 cancel. What is the VB is equal to? 2 volt. Now VB is 2, VA is 1, VA is 3. So what is the VOC? We are getting the same answer, yes or no? तो देखो आपने क्या किया, you have verified it, और in this way you get the how to solve the question. How to solve question, how to find the VOC, how to find the VB, how to find the VA, right? So that's why this will become what, when we are solving questions with different methods, with answers. So what will happen? We are getting the command over what? KCL, KVL, and that the diagram will become 2 plus 2 is equal to what? 4, like. Yes or no? So easy. So देखो और भी है different methods, you can solve it by the different methods. So you already we have find the RTH, already we have find the ISC, already we have find the VOC, that is the VTH, or we are getting the answer Thevenin's equivalent or Norton's equivalent. So are you ready to solve some more question? देखो सिंपल से उसमें भी आप कॉम्प्लिकेशन क्रिएट कर सकते हैं, क्वेश्चन को आप बना सकते हो. चलो आ जाओ, थोड़ा सा इजी सा क्वेश्चन देता हूँ मैं, बताओ जरा. नो ये वाला बोलिए. ओहो थोड़ा सा प्रिंटिंग मिस्टेक है इसमें. I will verify it and then I will give. This is the printing mistake, there is a problem. 1 minute. Next class we will solve with dependent sources, right? This one. Okay, बताओ, what is the answer? What is the answer for this one? The resistance are looking into the terminal A, B in the circuit shown in the figure will be. This is the resistance R, right? And that is the VCD, the C and D, and this is the VI. Okay. Tell me. We have 5 volt battery, okay, and then VI is connected here. If there is anything depend upon the VCD, I think no. Then when we are making the 5 volt short circuited, so what is the resistance seen by that path? Right, so that is open circuited. This is open circuited. When we are making the VI is equal to 0, that is outside of the circuit. We are making this is short circuit. That 1 ohm, that 1 ohm are in series, and that is the answer. 1 plus 1, that is the 2 ohm. Is it correct? This is a very simple 1 mark question. Yeah, okay. Then, so because RTHR looking into the terminal A and B is required, and therefore that will be the answer. Then on dependent sources we have number of questions. So in next classes we will discuss that with dependent sources. Today try to solve with independent sources only. Now tell me what is the answer for this question. The circuit shown in the figure, the Thevenin's equivalent of the circuit shown in the next figure. Find the value of open circuit voltage and Thevenin's resistance for this diagram. Watch this. This is the 12 volt battery, 6 ohm, 6 ohm, 6 ohm. This is the 1 ampere current source, but it is a direction is downward. Okay guys, tell me what will be the answer? What will be the answer? This is the 1 ampere current source. Then this is the 6 ohm. This is 12 volt. 6. And 1 6 ohm is connected here. And that is ground is also given. Ground is also given here. And you have a VOC and R1, means with this at this terminal A and B, you have to find the Thevenin's voltage and Thevenin's resistance. This is the 6 ohm and that is ground. 12 volt battery. No, this is the 6. Very, very easy. Tell me guys, what will be the answer? C. Bhanu Prakash, you are giving this answer C for that. Okay. Here we can apply what? Source transformation, guys. Here we can apply the source transformation. What is the source transformation? In this diagram, this current source can be converted into a voltage source. When I am applying, so 1 multiplied with the 6, this is converted into 6 into 1, 6 volt. Resistor, it is in series, that is the 6. There is another battery 12 that will be in series. Then there is another resistor here in a ground, because that is converted across like X and Y. This is X, this is Y. Here this is the current source is converted into a voltage source, 6 volt, 6 ohm in parallel series, then 12 and that is the 6. And here we are having one more resistor A and B. Now watch this. This 6, this is 6, this is the X and Y. This 6 and this 6 are in series, and watch the polarity, because it is a downward direction. So it is minus, it is plus. So it is minus, it is plus. Remember the polarity. Now the plus 12 minus 6. Plus 12 minus 6 is what? 6 volt, and 6 and 6 parallel 12. So you can draw a voltage source. 12 minus 6, that is the 6. In a series we are having one resistor, that is 6 plus 6, 12. Or here again we are having one resistor, and this is now open circuit voltage. And what is the value of this resistor? 6. Now this is what? 6. Can you apply voltage division rule? So VOC will become 6 divided by 12 plus 6. If you want to find the voltage across that, it is multiplied with the 6. So you will get the 2 volt. Okay, 36 by 18, 2 volt. And to find the Thevenin's resistance, make it short circuit, then 6 and 12 are in parallel. 6 and 12 are in parallel. What is the RTH? 6 parallel with 12, that is the 6 into 12, 72 divided by 12 plus 6, that is the 18. 72 divided by 18, that is nothing but 4 ohm. So Bhanu, you have given what is the answer? C. All other students, what is the answer for this question? So that is what? Yes, you have given the right answer, 2 volt and 4 ohm. 2 volt and 4 ohm. Okay, so this is the just a source transformation, or you can use any other method to solve this. You can just apply what very easy method you can apply. For example, for if suppose you don't want to make the source transformation, then always watch the direction of the current downward 1 ampere, because it will make you can do the what silly mistake here. Just to avoid the silly mistake, watch the direction carefully. This is the 12 volt, this is 6 ohm, and then this is the 6 ohm. Just I am giving you the another method. Ground. First, current source will act as open circuit, voltage source will act as short circuit. So first find the resistance here. So this will act as short circuit, current source will act as open circuit. 6, 6, 6, A, B. So 6 plus 6, 12. 6 parallel with 12. Already we have solved. And you will get the answer 4 ohm. Right? Now, which answer we have the 4 ohm? Only in one option we have the 4 ohm. In C. Is there any need to find the voltage? Tell me. अगर ये तो 2 सेकंड में बन गया, आप वोल्टेज सोर्स को ओपन कर दो, करंट सोर्स को शॉर्ट कर दो, एंड फर्स्ट ऑफ ऑल फाइंड द आरटीएच. Or in only in one option we have the 4 ohm. So MCQ, that's why it will become very easy sometimes. So this is the C, no need to find the voltage, right? Or, so that is the one way. And then, now suppose you want to find the, what is the voltage VOC? VOC. Then, again it is an easy method, right? You can choose a current I2 here, or you can choose a current I1 here in the direction of the current. So I1 directly you can say 1 ampere, or I2 into 6 is VOC. Now write down the KVL. So it will become minus 12 plus 6 plus 6 plus 6, 18 times of I2. देखो directly 6 plus 6 plus 6, 18 times of I2. And what is the direction of the I1? Just in the same direction. Watch this. In upward, this is also in upward direction. And that's why you can write 6 times of I1 also. Because it is also moving in upward direction. Watch this carefully. So I1, 6 times of I1, 6 plus 6 plus 6, 18 times of I2 is equal to what? 0. And what is I1? 1. It will become 18 I2 minus 12 plus 6 is equal to 0. So it will become I2 is equal to 6 by 18, that is 1 by 3. Now you have to find the VOC. So what is the VOC? 6 times of I2. 6 times of I2, that is become 6 into 1 by 3, and you will get the 2 volt. You will get the 2 volt here. That is the 2 volt. We are getting the answer same. So no need to always use the source transformation. Sometimes it will become lengthy. Otherwise, directly by using the mesh analysis or nodal analysis, directly you can solve. With the help of this, quickly you can solve the question. Quickly you can solve the question, guys. Okay. Very, very, very easy one. And that is the case. In this way we can solve questions. Okay. Hope you are getting all these points. So this is the questions on what Thevenins and Nortons with only independent sources. Now I am giving you the assignments. In next class I will solve. So first of all, with dependent sources, multiple questions I am going to give you. 1 minute. Now please take a screenshot. This is the 10ix, 4 ohm, 1 ohm, 2 ohm. This is the ix. You have to find the Norton's equivalent seen at the terminal AB. This is with dependent sources. This is with dependent sources. 10ix. Where is the ix? This is the ix. Right. So with the dependent sources, what is the answer? This is the assignment for you. Next class I will discuss. In comments box you can give the answer. Then next one, first question, homework. Then second one, 2ix, 5 ohm, 10 volt, 4 ohm. Here it is the ix. This current source, this is the current controlled current source, depends upon this ix. Find the value of ix and then find what VOC and ISC or Norton's equivalent, or you can also find the Thevenin's equivalent for this. In next class we will discuss both Thevenin's equivalent as well as Norton's equivalent for this diagram with dependent sources. So second question, homework on 24th. So you have Saturday, Sunday in between. So try to solve this question. This is a important one. Then I will solve this question for you. This is the Vx. This is the 2Vx. This is the voltage control voltage source. And we have 2 ohm resistor parallel to voltage source. So what is the role of this 2 ohm resistor? I will explain. This is the 5 ampere. This is the 4 ohm. This is the 6 ohm. This is the 2 ohm. Across A and B, you have to find the Norton's equivalent as well as Thevenin's equivalent. Both. Thevenins as well as Nortons. Yeah. So what is the answer for Norton? And then you can find the Thevenin's equivalent across this. This is a very, very important question, right? तो ये भी homework है. That is the third one. Hope you are enjoying the session. Yes or no? I have solved selected numericals, but in every numerical you will get what some basic idea. In next class I am going to solve some very, very important numericals, guys. So this is my Telegram channel. If you want the PDF of this session, then you can join this Telegram channel, Electronics by Sanjay Rathi, where I will upload and share the link with your friends so that they will join. This is a new channel, guys. Okay, मैं नया नहीं हूँ, 24 years है. Already my videos are available on different platforms. But here you can interact with me. You can ask some questions. कुछ ग्रुप बनाएंगे जहां आप मुझसे लाइव इंटरेक्ट कर सकते हो. लेकिन बस एक टारगेट याद रखिए कि इन एग्जाम्स में हमको अच्छे नंबर लाना है. Only 17 to 18% students are qualifying the GATE examination. So IISc Bangalore release some data. Please go through that. नेगेटिव मार्क भी आए, 0 to 10 मार्क्स भी आए, 10 to 20 मार्क्स भी आए. अदरवाइज वन वीडियो इज अवेलेबल ऑन दिस चैनल, गो थ्रू दैट. तो उसको देखकर आप ये देखो कि कैसे प्रिपरेशन स्ट्रैटेजी क्या होना चाहिए. व्हाट शुड बी द स्ट्रैटेजी सो दैट इन गेट 2025 और इन 2026 और एनी अदर कमिंग एग्जाम यू आर गोइंग टू सेलेक्ट. ठीक है, कैसे सेलेक्ट होना है, फुल प्रूफ स्ट्रैटेजी बनाइए. दैट्स व्हाई आई एम गोइंग टू टेक इंपॉर्टेंट सेशन. दिस इज द शेड्यूल फॉर द नेटवर्क. Why? Because network is one of the most important basic subject. And then this is the Thevenin's and Norton's theorem with dependent sources, where I will solve all the basic question. Please note the time, 24th of June, 4 p.m. Okay. Okay then guys, thanks. Thank you very much for attending the session. Like the session, share the link of this session. Press bell icon and subscribe our channel now. Thank you. Have a nice day.